So I guess the question is here for this one. Doesn't look like it wants to record. Maybe it'll record, maybe it won't record. It's kind of spinning its wheel. Oh, there it goes. All right. So to determine the zeros of this piecewise function, we're basically trying to figure out where the y values would equal 0. Okay? And so in this case, could this ever equal 0? Let's think about something squared. Is that going to be a positive or negative? Plus a positive. So if you have a positive plus a positive, will that ever equal 0? No, never equals 0. So this will never have a 0. How are we going to find the zeros for this other piece? Factor, yes. This is going to be your x minus 4, x minus 2, right? We set that equal to 0. We'll see that it's going to be at x equals 4 and x equals 2. Do those two values fall in its domain? Yes, they do, right? So it's going to be at 4, 0, and 2, 0. And we can go ahead and put those on the graph. So we can put 2, 0, and 4, 0. So we know it's going to go through those 2 points as well.
What do we do if that doesn't fall?
You don't include it. So you just wouldn't even put it at all, right? So if one of the zeros was like, say, -2, well, of this function, we wouldn't include it because that function wouldn't even exist at x equals -2. Okay? All right, so now we're going to start looking at all the first derivative information. So the first thing we're going to do is we're going to go ahead and get the first derivative, right? So f prime of x equals, and so we just take the derivative of each piece, right? So this first piece, just 2/3, just using our power rule, and then drop it 1 power. So we drop it 1 power, so that's going to be -3/3, which is going to be -1/3. And then the derivative of 2 is just 0, so we don't have to have that. This is for x is less than 1. And then over here, we'll take the derivative of that, which would be 2x minus 6. This is for x is greater than 1. Right? So those are the derivatives of each piece. And so now we're going to want to analyze the derivatives. We're going to make a sign chart. And so when we make a sign chart of a piecewise function, what I'm going to want you guys to do is I'm going to want you to always put where the two pieces come together, like the two pieces are meet or break, or where it splits right there between the two pieces. I want you to put that on your sign chart. And I like to put a little barrier right there to let me know that 1/2 of this sign chart is going to be dealing with, one piece of the function. The other half is going to be dealing with the other. And so on this left half, where x is less than 1, we're talking about this one. So we're talking about f prime equals 2/3. And I'm going to rewrite this without a fractional exponent, so it's a little easier to think about. Thinking about x to the -1/3, that's really the cube root of x in the denominator. Right? So the negative puts it in the denominator. The 1/3 power is the cube root. So that's one derivative. The other derivative over here, I'm going to put on this side, which is 2x minus 6, because that's for where x is greater than 1. So now I can actually find where each of these equals 0 and put those in our sign chart. So the first one, is this ever going to equal 0? F prime of 2/3.
No.
Yeah, this is never going to equal 0, right? But will it ever be undefined?
Yes.
Yes, this is undefined at x equals 0. Because if we put in 0 here, we're going to have division by 0. So we're going to include 0 right there. All right, how about on the right-hand side? Will this ever equal 0? Yes. What value will equal 0? 3, and it falls within its domain. So we're going to go ahead and put it. See, if you set it up like this and you get a number like -3, you know it doesn't fall within its domain. It's real easy to see not to include it. Okay? But in this case, we're going to include these. All right, so now what we want to do is we want to go ahead and get all of our sign chart. So whether f prime is positive or negative. And so I'm going to pick a negative number. So if you take the cube root of a negative number, it's still negative. Like the cube root, for example, cube root of -8 is -2. So the cube root of a negative number is still negative. And so we're going to have a positive over a negative, which is a negative. Then I'm going to pick a number like 0.5. And I don't really care what the cube root of 0.5 is, but what I do care is that it's going to be positive. So I know I'm going to have the denominator is going to be positive, the numerator is going to be positive, so they're positive. Then I'm going to pick a number over here at 2 between 1 and 3, and now we're going to plug it into this other derivative, our 2x minus 6. So I plug in 2 over here, I get 4 minus 6, I get negative 2, which is a negative. Then I'm going to pick a big number greater than 3, like 18, and I'm going to get a positive. And so I should see that our graph should have this kind of look to it. It should be decreasing, then increasing, then decreasing, and then increasing, right? And so these are the intervals of increasing and decreasing. So let's go ahead and put those on here. So it's basically telling us our intervals of increasing or decreasing. We know we're going to be increasing from 0 to 1, and we're also increasing for 3 to infinity. This is what we're talking about. We're talking about, this is not f prime increasing or decreasing. We're talking about the actual graph that we're going to draw. The f of x graph that we draw should have these intervals of increasing and decreasing. And we're going to be decreasing from negative infinity to 0, and then from 1 to 3. Everybody good with that? That's what the sign chart tells us. It tells us on what intervals is f of x have a positive slope and what intervals does it have a negative slope. Okay? Where will it be increasing? Where will it be decreasing? All right, and so now, I have this thing on backwards. Oops, he's driving me crazy. Sorry. All right, up here, as far as critical numbers go, that's where f prime equals 0 or is undefined. And so those are those three values right here, 0, 1, and 3. And so you might ask, well, how do we know that f prime of 1 doesn't exist, right? Well, the two pieces, when they come together, they don't actually equal each other. It doesn't equal 0 right here at 1. If I were to plug that in to both these, I would get 2/3 and I would get negative 4. So there's going to be a sharp corner right there at 1. Does that make sense? There's going to be a sharp corner. The slopes from both sides do not match. So it's going to be an undefined slope. So we're going to have a critical number there as well. So our critical numbers are going to actually be at 0, 1, and 3. It's not because there's just a maximum at 1. It's really because there's going to be a sharp corner on that when those two pieces come together. And so then our relative maximum, where's that going to be? Looking at our sign chart, where's our maximum is going to be? At 1, right? That's where f prime changed from positive to negative. So we went from increasing to decreasing, right? So f of x went from increasing to decreasing because f prime went from positive to negative. So there's going to be a maximum at 1. We already know the y coordinate at 1. It's 3, right? So that's already the point that exists right there, 1, 3. The minimum, we're going to have a minimum at 0. Then we have to figure out what is the y coordinate going to be. We'll come to the original, plug in 0 into here. Looks like it's going to be at 0, 2. This is going to fall in that domain right there. So it's 0, 2. And then if we plug in 3 is also going to be a minimum. And so we plug that back into this original, and that's going to be 9 minus 18, which would be negative 9, plus 8 would be negative 1. And so we can put those points on the graph. So we already have 1, 3, 0, 2 goes right there, and 3, negative 1. So notice, things that I plugged into the original, they're going to be able to go on the graph, right? Those are points that we're going to be able to put on the graph. Questions over that? Anybody have any questions over the first derivative? Anything the first derivative can tell you? Yes?
Just leaving the ones where it says,
Yeah. So yeah, what happened is that originally I had just like a straight function, not a piecewise. And so you could actually write the derivative in there. So we're going to leave those blank. Now on questions 3 and 4, you can actually write the first derivative and everything. Any other questions? All right, so now let's look at the second derivative. The second derivative can tell us these things. And so we're going to go ahead and take the derivative of our derivative, right? So our second derivative, f double prime. And so we're going to go ahead and take the derivative of this. And so when I multiply in front, I'm going to end up with negative 2 over 9 x to the negative, and I have to subtract 3/3 from that. And so that's going to be negative 4/3. This is for x is less than 1. And then over here, we're going to end up with 2. This is for x is greater than 1. And so we're going to make a sign chart again. So our sign chart, always we're going to include where the two pieces come together or break, where the breaking point for the piecewise function, where those two pieces come together. And then I think on this side, it's, this side is 2. And this side over here, for x is less than 0, it's going to be your negative 2 over 9. We have to, again, be able to write this correctly. That makes sense. How we wrote this. Because if you can't figure out what these are, then it's going to be really difficult coming up with your sign chart. So hopefully easily on the right-hand side, since f double prime is 2, is that 2 a positive or negative number? Positive. So it means we have positive second derivative for every value greater than 1. Right? So it means we're going to have a concave up function. Now, again, we've got another division by 0, so we're going to include 0 on our sign chart as a possible point of inflection. So I'm going to plug in a negative. What happens when I put in a negative into x to the 4th? Positive, right? So we have positive, and so the cube root of positive number is still positive. So the denominator is going to be completely positive, and you have negative 2 over a positive, which is going to be negative. And then if I put in, say, 0.5, it's going to be positive, and so our denominator is still positive. So we have a negative over a positive. So we didn't get a sign change right there. So notice, we didn't get a sign change when we had this even power right there. The even power made it so it wouldn't change signs. All right, so now we can go ahead and look to find where's our point of inflection. Well, only point of inflection is going to be at 1. That's the only place where the second derivative changes signs, where the concavity will change signs, right? So we're going to have a point of inflection at 1, and we already know the point there. It's the 1, 3. It's still that same point, 1, 3. But then concave upward is going to be from 1 to infinity. And concave downward, I'm not going to be too picky. You can do it either way. You can either do from negative infinity to 1, or you can do it in 2 separate negative infinity to 0, and then from 0 to 1. Because when you see the graph, it almost looks like at 0, it doesn't really, it's not concave up or concave down really there. But I would not count it wrong if you went from negative infinity to 1. I would count that. All right, so now let's go ahead and let's make sure we get everything listed correctly. All right, so we've got this side of the graph. It's going through these 3 points, and it looks like it's going to be always concave up. And so we should be able to just draw a curve. I'll draw it in green. Should be able to draw a curve that just goes through those points and is concave up. That's the right half of the piece. And hopefully that makes sense because it is a parabola facing upwards. So it should look like a parabola facing upwards on that side. Okay. This left side is a little bit trickier. So we know it's going from here to here, which is said it was increasing on that interval from 0 to 1, but we're also concave down. So it should be concave down, increasing like that. So it should be draw a little more exaggerated, like, some sort of like concave down, increasing. And then on the other end, over here, we're going to be decreasing, concave down, right? So we're going to be decreasing in concave down. So something like that. And that would be our graph. And then notice right here, so we said this was going to be a non-differentiable point because the slopes didn't have the same value coming into them. We're going to be a sharp corner right there, right? Because when we plugged in 1 into both of these pieces, we got 2/3 on the left-hand side, and then we got 2/3. Oh, we're talking about 1. Okay, good. I was about to think that does not look like a slope of 2/3 right there. No, yeah, right here. At 1, we had 2/3 on this side, and we had -4 on that side. And so you can see there's a sharp corner there, so the derivative didn't exist. This one right here, where the derivative was undefined, again, it came out and looks like a sharp corner at that spot where the derivative was undefined, okay? Where we had that derivative equal division by 0. Questions over that? I can put the hardest, this is the hardest one, okay? The other one should be a little easier, but if you have any questions over any of this, if you have any questions over anything we did here. So this kind of ties in both of the things we did the last 2 class periods into how is it going to look, how is it all going to be related, how is it all going to fit onto the same graph. Okay? Everybody good?
Is this going to be on the quiz form?
So what I'll say is, like, you're not going to have to do a question like this on the quiz, but what will you have to know? You'll have to know how to find maximums and minimums. You'll have to know how to find intervals of concavity. You'll have to know what a critical number is. You'll have to know on what interval something's increasing, decreasing based off looking at the sign chart. So are we going to put it all together in one question? No. But all the different pieces of this, yeah, are all things that we have been doing. So this shouldn't have been anything really new as much as you're just kind of seeing the whole thing together. Does that make sense? Okay. All right. So I'm going to let you guys have the remainder of today to work on this. This is going to be due. So you've got about, you got a good amount of time. Let me turn this off. So we got about 25